Imagine standing on a city street and watching a skyscraper breathe. The glass shimmers, not from pollution, but because it's consuming it. Every panel acts like a living lung, drawing in smog and exhaling oxygen-clean air. The walls hum with captured sunlight, generating their own power. The building doesn't drain the grid. It feeds it. It sounds impossible, yet it's happening right now. From Milan to Mexico City, Hamburg to Singapore, architects are using nanotech and renewable design to turn the skyline into an environmental engine. These are regenerative buildings, structures built not to survive a polluted world, but to heal it. For centuries, architecture has protected us from nature. In the 21st century, it's starting to protect nature from us. Here's the paradox. The world's cities occupy less than 3% of Earth's land, and yet produce over 70% of its carbon emissions. Each megacity functions like a heat battery, cooking itself each summer while suffocating its residents with trapped smog. But what if skyscrapers could reverse that equation? What if the same concrete that warms the planet could one day cool it? What if the city itself became a renewable ecosystem, each window, wall, and rooftop alive with chemistry, light, and biology? In the next few minutes, you'll see the science turning that fantasy into reality. Titanium dioxide-coated towers that eat nitrogen oxides, facades that generate electricity, and living walls that photosynthesize like trees. Because beyond the smog and glass of the modern metropolis, a new skyline is rising, one that doesn't just change how we live, but how cities breathe. So let's start where it all begins, with the pollution paradox at the heart of every city on Earth. Every modern skyline hides a quiet emergency. Cities, the ultimate human invention, now rank among our planet's most aggressive polluters. High-rises glitter, streetlights pulse, HVAC systems hum day and night. Yet behind the glow, those same structures are responsible for nearly 40% of global carbon emissions. Each building acts like a thermal sponge, absorbing sunlight all day, releasing waste heat all night. Asphalt, concrete, and glass trap radiation until the air itself thickens with heat. Stand downtown at midnight in midsummer. Temperatures still hover far above the rural horizon. This is the urban heat island effect, the invisible tax every city pays in electricity, health, and lost sleep. Then add the smog. Vehicle exhaust, industrial fumes, and air conditioning gases swirl together into a chemical haze that kills 2.4 million people annually. More than malaria or HIV/AIDS. In Delhi, Mexico City, and Beijing, visibility can drop to a few meters. In Los Angeles, nearly 80% of residents breathe air considered unsafe by whose standards. The structures meant to shelter humanity have become engines of its discomfort. Walls and roofs designed for climate control are sealing us off from natural airflow, forcing the use of yet more energy to fix the problems we create. It's a feedback loop of brilliance and blindness. The smarter our cities, the hotter and dirtier they grow. But here's where hope cracks the smog. For the first time, material science, nanoengineering, and AI-based design tools are aligning to reverse this chain reaction. Think an apartment block that doubles as an air purifier, a hospital that generates more energy than it consumes, a city block that cools itself. The technology exists. It's already glowing quietly on a facade in Milan. Next, we'll step into science that makes it possible, the chemistry that lets a wall eat pollution. Step closer to one of these new facades, and you're looking at chemistry disguised as art. To the eye, it's just smooth ceramic tiles, pale and luminous. But under the sun, each square meter becomes a microscopic reactor, a living filter built from light. The secret ingredient is titanium dioxide, or O2, a pigment once used in sunscreen and paint, now transformed into one of the most powerful photocatalysts known. When UV light hits those particles, electrons leap to higher energy states. That split-second reaction creates radicals, tiny chemical warriors, that tear apart the nitrogen oxides, sulfur compounds, and volatile organic molecules that make up urban smog. Here's the elegant twist. The catalyst isn't consumed. It keeps working indefinitely, powered by sunlight and a hint of humidity. A single building in Milan, the 16-story De Castilia 23 complex, neutralizes up to 59 kilograms of nitrogen oxides a year. That's the equivalent of planting 200,000 square meters of forest or removing 8,700 cars from a road. Rainfall rinses the surface clean, washing away residual dust and salts. The facade literally refreshes itself. Other cities are following. Mexico City's ceramic hospital walls strip toxins from the air of one of the world's smoggiest capitals. Researchers in Eindhoven extended the concept of roads, laying TiO2 coatings that reduce roadside pollutants by nearly half. Add sensors, and the system becomes smarter. Imagine walls that know when air quality dips and widen nanovalves to expose more reactive surface area. Roofs that shift panels to catch optimal sunlight for photocatalysis and solar generation simultaneously. What began as pigment has turned into planetary strategy, buildings as the lungs of the metropolis. But purification is only the first act. These structures don't just clean the air, they power themselves. Let's unlock the energy systems hidden inside. Cleaning the air is just the beginning. The second revelation is that these same buildings feed on sunlight, literally generating their own power. Instead of adding solar panels as an afterthought, engineers now weave generation into the architecture itself. Transparent photovoltaic glass replaces windows. Thin film cells cloak facades in invisible circuits. It's called building integrated photovoltaics, BIPV for short, and it turns every wall into a vertical power plant. A tower that once leaked energy now produces 4 times more electricity than a rooftop array alone. Step inside, and you'll find the walls breathing heat, too. Hidden layers of phase-change materials store excess warmth during the day and release it at night, trimming temperature swings by nearly 30%. The result, less energy spent on air conditioning and offices that feel naturally tempered even under extreme heat waves. And in Hamburg, Germany, a prototype known as the BIQ house takes the idea to the edge of biology. Its facade hosts panels of living microalgae, microscopic plants suspended in glass bioreactors that photosynthesize sunlight into fuel. As they grow, they absorb carbon dioxide, cast cooling shade, and can be harvested for biogas energy. Each cubic meter of algae equals a carbon-capturing power of almost 100 trees. Architects call this the moment when buildings stop acting like consumers and start behaving like ecosystems. Smart microgrids connect each facade, window, and roof, balancing energy across districts. When one block overproduces, another draws from it. The city begins to think like a single organism, managing its own metabolism. It's a breathtaking inversion. For thousands of years, structures depended on the grid. Now the grid depends on them. But there's an even larger level of design emerging, where entire neighborhoods become regenerative networks. So how do you make an entire city that eats pollution and powers itself? Look across a glowing skyline at night and realize those lights could soon represent not consumption, but restoration. Every facade quietly breaking down smog particles. Every window pane producing current. Every roof stabilizing the planet's fever by storing heat when it's abundant and releasing it when it's scarce. That's not abstract sustainability. It's a new metabolism for civilization. Humanity's oldest technology, the building, is learning to give back. From Milan's photocatalytic towers to Hamburg's living algae houses, each prototype proves the same principle. The city itself can heal when you integrate renewable energy, living systems, and sensor intelligence. An entire district behaves like an ecosystem, self-balancing, adaptive, alive. Imagine walking downtown where the air feels fresher after traffic, where walls change color as they process sunlight, and where no one thinks of waste heat anymore because every joule finds reuse somewhere else in the grid. It's the kind of progress you can literally breathe. But for the promise to scale, policy, economics, and design culture must evolve together. Construction codes written for concrete and glass must include carbon-negative materials. Developers need incentives that count cleaner air as profit. Citizens have to expect buildings that give more than they take. Once expectation shifts from less bad to net good, regeneration becomes the standard blueprint. The miracle isn't just the science of titanium dioxide or transparent solar cells. It's the mindset that the built environment is no longer separate from the living one. The moment we accept that, the modern metropolis turns from patient to doctor. Next time on Urban Pulse Innovate, We'll explore that next transformation. AI-orchestrated digital twins, virtual copies of entire cities that predict pollution, traffic, and energy flows before they happen. The technology that makes healing skylines possible will soon make self-aware cities a reality. Because the future doesn't wait for permission. It's already under construction.